the application, on the more on the engineering level of a battery system, because I think this is important, because the safety of the battery is what everyone's need to consider, even when you start from the fundamental material design all the way to the engineering applications. So my first slide, I think if you may, as some of you may have seen this picture before, is the timeline of battery commercializations. So all the way back from 1748 and until the 20s, we can see how the battery as energy storage evolved. Is particularly during my lifetime, I don't see anything that is so much powerful as compared to any other development. So because of the development in the battery technology, then we have the invention from a small scale application all the way now to the big scale, like the cars, utilities, the trucks and everything. So all of this made possible is because we have a unprecedented battery improvement throughout the years and years of research and development. This is where we go from here to the next 10 years. As I think all of us can see, or all of us can predict, that it will only go further and better, and eventually that with the hope that at one point we are no longer depends on the fuels and the fossil fuels, the petrols to live with. So when you talk about the battery management systems, as we know, the materials in making the battery is improving every day. So every day there are thousands of researchers around the world are making a good battery to increase the battery lifetime, to increase the battery capacity, the energy density, and also to increase the safety of the batteries. But we also have to be very conscious in using the battery, particularly in the large scale applications, because as we know that in large scale application, we need a lot of batteries that can connect in series and parallel to make the system works. So taking as examples, let's say for a Tesla car, I think this is a well-known knowledge. In a Model S Tesla car, we have 7,800 of the 1865 of the cylindrical cells battery. There are more than 7,000 of them. They are all connected in series and parallel just to enough to power the car. So with this large amount of battery cells, we need a battery management system. So a battery management system, in my own definitions, I will break it into 3 Ws. So what is it, why, and which? So as we can see from the slide here, so what is a battery management system? So if you see any battery pack, a large battery pack, you have a set of electronic system that printed on a circuit board, and also connected along with the battery cells, some solid state devices, for example, like the fuses, the relays, things that you can see around the battery pack. Those all together are called battery management system. And why we need those systems? Because in the battery pack, the battery itself is actually a passive device. We have to control the charge. We have to command the battery when to release the energy and when to stop releasing the energy. So this is why the function of a battery management system, or in short form, we call it BMS, is we want to prevent the abuse condition and want to monitor the critical parameters and to communicate the information from the battery pack to the rest of the systems. So which kind of design, which kind of battery management system that will be used for any type of applications? So as we know that the range of application for battery is unlimited, is huge. The potential of battery application in every day of our life is huge, is tremendous. So the degree of the design implementation of battery management system varies substantially depending on our requirements, because we know that every different requirement have every different size and capacity of the battery cells, and every battery chemistry need different battery management system. And also that in terms of business, you have to think about the cost effectiveness and the performance expectation. Of course, the higher performance you expect, the more expensive the battery management system will be. And the main questions that some people ask, what if we do not have a battery management system in the battery packs? So this is an experiment that I have done before in the last couple of years. So if you see in this experiment that we have a battery packs. This is just inside here is just 20 cells, 20 lithium iron phosphate cells, and we built this case. We built the enclosure, right? We built the enclosure with the hole here so that we can abuse the battery, and we have a battery management system here. But this battery management system, we don't work. It's not a working battery management system. We just put it there just for the illustration purpose. But this BMS that we built here, we stop it from working. That means that we want to see what if don't have battery management system, what will happen to the battery. So we overcharge the battery. We charge the battery, and because don't have the battery management, so we overcharge it. So this is we simulate the real life scenario. What happens if the battery management system is not assistant or it's malfunctioning, it's not functioning? So the battery will get overcharged or over discharged. So if we overcharge the battery, as you can see, luckily I performed this experiment outside of the room. If I perform this inside in the room, if I perform this experiment inside the room, I might not be even able to talk to you guys here today. So as you can see, the impact of just only a 20 cells battery, if you overcharge it, it exploded. It exploded that it generated high pressure, it generated high temperature, and it cascaded the pressure up to 0 megapascals. It blow the enclosure. The enclosure is a 4 to 6 mil thickness of a mouse steel. It's a very heavy enclosure, very thick enclosure. It blow the enclosure into pieces, and even blow the metal door. If you see the metal door, the shape of the metal door is actually is no longer in the original position. So the impact of just 20 cells connected in series, if without a battery management system, then the impact is catastrophic. So life is important, and this is why that we know that batteries are important, but only if not compensating the life and loss of properties. So imagine that if we use in an electric car or as an energy storage system, if the battery management system is not working, and the battery is overcharged or over discharged, or run into the thermal abuse, the effect will be significant, and in fact it will cost life and loss of property. So the key thing here is the BMS is to protect the safe operation, to ensure the performance that up to the specifications, and also the most importantly as well, to increase the battery life, because if we increase the battery life, we increase the effectiveness of the operation, and also the adoption of battery. And the end of line management. End of line management is what happened if after the battery retired. So we need a system. We need a battery manager to tell us which battery is going to retire and which battery is can be used as a second life. So this is why we call it EOL management, and it's all based on the battery management systems. And in battery management system, we have primitive and advanced. Primitive means is the fundamentals. So for the primitive or fundamental battery management system, it's only have the basic function. It's meant for the application that is used for small power requirement. So for example, if you can see from our smartphones, laptops, tablet, power tools, and personal care. So all of this, we have a tiny electronic circuit board or chips that built inside these small devices, and there is also considered battery management system. And and they have only the standard feature. What is the standard feature they have is to protect the battery from overcharge, overcurrent, and of course, to ensure the battery operate in the temperature that is permissible for the battery. And that's a primitive design. But if you come to the big scale, a big scale for example like EV and the and the energy storage system, you can see we need an advanced battery management system. So advanced battery management system, basically, there are a lot of researchers around the world perform a lot of research and development, and it's still ongoing. So there are limited opportunity. The sky is the limit for the development. You can put anything you want in a battery management system, or you can design how smart you want to be and how safe you want to be. So there are plenty of choices that how we can make the battery management system to become intelligent and more advanced. And as I mentioned here, is advanced battery management system is currently employed in a growing market like for the transportation, the automobiles, the automotive industry, and also the renewable integration. So like for the solar farm, wind farm, together with the battery energy storage. And it is meant for the large scale and large capacity battery pack with multiple of them connected in series and parallel to accommodate the related power requirements. As well, battery management system, advanced battery management, it have because it's applied to large power application, it have to be accommodate the certain industrial standards and have to comply to the regulations to ensure that the operation is safe. And there are few of the industry standard that do this, and which I will explain later in the later slides. So an advanced or a good battery management system actually is a key factor for any organization that in this business, because with advanced BMS system, the organization or the company can monitor the performance and the degradation of the batteries. Because when we're talking about large scale battery, it's important that we have a system that can manage the batteries. Because if we don't manage properly, it will cause a significant amount of losses to any organization that operate the such amount of large energies. I include here, as you see, one of the graph that predict the future of lithium-ion batteries markets, and we can see that it started all the way back from 2006 and all the way to the next 10 years. The significant and drastic increasement of the of the usage of lithium-ion batteries in automotive and also in the energy storage. So over the last few years, as you can see from here, the EV and stationary energy storage has taken place, and we predicted in the next coming 10 years, this value will increase drastically. So if you talk about sorry, if we mention about advanced battery management system, how advanced you want it to be. So when we have an advanced battery management system, we will include a very intensive algorithm that we can calculate and predict the battery state of charge, the battery state of health, the performance, the functionality, and etc. So why we need to predict the battery state of charge? Because the battery state of charge cannot be measured. State of charge is an imaginary number. So it's an imaginary words, because on the battery terminals, we can only measure the voltage, the temperature, and also the current. But that doesn't represent the state of charge of battery. That means that does not give us the information. That does not give us the direct information about the current energy left or current capacity that the battery has. So we need to have an algorithm. We need to have an algorithm or a methodology that from these measurements, then we can calculate, or we have a methodology to predict or to estimate the leftover energy of the battery cells. Imagine, imagine that we have a system that consists of thousands of battery cells. And every battery cells, we need to have the calculation of the state of charge and state of health. So imagine that how complex the system will be. That's right. The battery management system, the research and development into battery management system is a field that that has been performed over the last decades, and because of the complexity of the battery when they apply in the large scale format, is well acknowledged, and with all this complexity, like for example, in any of the cell with all that complexity, we need to have a proper algorithm in the battery management system to fully protect the battery and to prolong the life of the batteries. So taking into consideration also that every battery cells that come up from the same factory, the same manufacturing date, they have a different behavior after a certain time of operation in the field. They have a different life cycle, different temperature behavior, have a different state of charge, different degradation, even though they come out at the same time, same day, and same place. So, so this is why the complexity of managing a large-scale battery system is actually well acknowledged, and up to today, there are still not a standardized battery management system as yet for large-scale battery system. Besides the algorithms, advanced battery management system also incorporating thermal management systems. As you know, that if in a large-scale battery system that consists thousands of them, the temperature distribution is different across every point or every edge of the battery. And it's important that in this temperature management system that we can try our best to homogenize the temperature distribution, because the battery behavior changes with temperature. So for us to have a homogeneous system, to homogenize the whole cells in the pack, effective thermal management system is very important to ensure that the temperature is equally distributed across the batteries pack. Sorry. And the last but not least, I'm sorry. Sorry, not last but not least. The third one is the battery balancing system. As I have mentioned just now as well, even the batteries pack consists of the cells that produce at the same time and same place and same materials. over time, each of them behave differently. So they behave differently, it means that their capacity change to difference, and they need the time for them to charge to full cells, to full state of charge is different, and the time for them to discharge to the lowest state of charge is still different. So because of this disparity between each of the cells, an effective balancing system is very, very important to ensure that all the cells in the battery pack charge and discharge to the same rate. If we do not incorporate the battery balancing systems, then the battery performance is not fully optimized. And the last but not least, so how advanced is when we see something is involve the phone, involve the tablet, involve the computers. This is all the communications. So, and the data management and network. When we have something that involves in networking, then we can see something as cloud. We can see something as advanced. So why we need network in battery management system? It's important because the data that we measure on the battery at every seconds or every hours, it has to be stored. And if we store locally on the vehicle platform itself, on the application platform, then we stress the design requirements. So if we stress the requirement, that the whole application become very expensive. It's not cost effective. So in order to store the data, the huge amount of data, we need a effective communication system and storage system. Sorry. It's effective in a way that the data pass to the cloud server, and the cloud is to manage all the data through machine learning system or through artificial intelligence. And from this data, it predicts and will give us the state of health of the battery, the performance of the battery packs, and even the the safety factor, the safety factor that of concern to the battery packs. So reliable and proper data management from the battery management system is extremely important, because the data history of what measure from the application will allow us to predict the future behavior of the battery packs. And that is actually to also facilitate the end of life of the battery. End of life means that we need to know when the battery packs or the battery systems will stop functioning or will reduce its capacity, because we know the battery doesn't run forever. It has a cycle life. And to measure the cycle life, to estimate the cycle life is it's not a straightforward calculation. It needs to have a data history, and we need to have an algorithm to predict. Sorry. So we talk about the safety aspect. Yeah.
Excuse me, Dr. C, you have 5 minutes.
Yeah, sure, no problem.
Okay.
Sure, yeah. We talk about the functional safety. So the safety to the BMS is important. As I mentioned, the purpose of BMS is to ensure the safety of the battery packs. So how do we know that we build something that is safe? So this is why we have an industrial standards. The one that we have is called IEC 61508. So IEC 61508 is an international recognized standards, and it's a methodology assessment that the software and the hardware that we design is in accordance to the access industrial protocols. In that case, we will ensure that wherever we decide to protect the battery, it's really working. So as far as I know, there are not many BMS in the world that have this standard. But what is going on now in the future, I think the industry will require this standard to be applicable. So battery thermal runaway. It's important that we need to design the battery enclosure in a way that it can sustain or protect the cascaded thermal runaway. Because the battery management system is the first line of design. So what happens if the BMS or the battery management system is not working? So because BMS is an electronic box, and we know that electronics sometimes have their malfunctionality. So in the worst case scenario, what happens if the BMS completely not functioning? We still need to design in a way that the battery enclosure is important. This mechanical design. The battery pack enclosure the design is important in the way that we can prevent the cascaded thermal runaway so that it will not happen the explosion, just like I showed you the picture just now. This is also in regards to the mechanical design of the system. So what is the future lies here? The future lies here is safety is above everything. we can have the most advanced system in the world, but without safety, the advanced system will not be deployable, will not making sense. So we need safety above everything, and with safety comes that we have all the intelligence, and we have all the smart that can be employed into battery management system. Because intelligent system has no limit. Whatever function you put into BMS, if you first ensure the safety is in your hand, then you can use your creativity and innovative to create how smart your BMS will want to be. So I want to end my slide that to introduce to all of you the place that I work. I live in Australia. This Wollongong. It's near to the beach. This is our facility. It's just 5 minutes to the beach, and this is the first facility in the country that actually that bridge the gap between the fundamental material study and all the way to commercializations. So in these facilities, the group that I lead have actually commercialized a lot of advanced battery management system, and also have made a lot of battery packs for the industries, and particularly for the mining industries, we have commercial a lot of our battery pack technology for the local industries. So I welcome all the participants and students to come to our facility in the future, and I look forward to work with you all. I hope to see you. And the last but not least is thank you again for the organizer, and thank you for all participants.